Today I want to talk about lifespan development. This would be Chapter 9 in your textbook in the Chapter 9 lecture PowerPoint. This is actually a thumbnail of a course that we have called Human Development. Sometimes you'll see it as Human Development. It's either Lifespan Development or Human Development. If you like this chapter, and a lot of people do like it, or in some cases you may have to take it as an elective or even requirement for whatever program you're in, we do have an advanced course in this called Human Development that you might be interested in taking. But I always ask this question of my students: how long do you think, or at what age should we say, do you think we stop developing? And when I ask that question, I often get some interesting answers. The most common ones being that we stop developing at 18, or sometimes I'll hear some people say 21 or 25. Well, actually, when you think of development, don't think only in terms of physical or physiological development. Think in terms of change. So when you see lifespan development, think of it as lifespan change. So when do we stop changing? Well, the answer to that is we never stop changing. So we basically change throughout the lifespan, and that's what the lecture is all about: is how we change throughout the lifespan. Just a little bit of background before we get into actual developmental psychology. I want to talk a little bit about behavioral genetics. Sometimes this is known as behavior genetics, which is the study of human differences in the effects and interaction of environmental and hereditary factors. A few terms that I want to mention here that I may refer back to as we go through this chapter, just so we're all on the same page. One would be DNA, which I'm sure you're familiar with, which is deoxyribonucleic acid, complex molecule housing genetic information comprising a chromosome. And a chromosome are individual thread-like structures composed of DNA and housing genes. Information resulting in the development of chromosomes originate with both the mother and the father, each contributing 23 pieces of information for a total of 46 chromosomes. And a gene is a DNA segment with protein synthesizing capabilities, biochemical hereditary units comprising chromosomes, and of course genes we're going to talk a lot more about as far as how we transfer genetic information through DNA. Okay, chromosomal influences sex determination. Of the 46 chromosomes provided by a child's parents, 44 are common to both males and females. The remaining 2 chromosomes determine the sex of the child, and actually, as we're going to see, 45 chromosomes are actually unisex. So that's how similar males and females actually are. Ova always contribute an X chromosome, and that, of course, is provided by the female, whereas spermatozoa contribute either an X or Y chromosome. So in this case, you see that it is the male, or the father actually, who basically provides the determining information as to whether a child is male or female. An XX chromosome pairing represents a female sex determination, and an XY pairing represents a male sex determination. We do have some rare instances of chromosomal variations that can result in developmental or other disabilities. The most common that we tend to see, which is about 1 in 691 births, may be noted in Down syndrome, or sometimes you'll see this as Down's syndrome, where an extra copy of chromosome 21 may result in mild to moderate physiological and intellectual challenges. Other chromosomal variations may result in alterations in sex characteristics, such as Klinefelter syndrome, which we would see in XXY, affecting boys, and triple X syndrome, or XXX, affecting girls. Now, we're talking about gender and development. Really, the genders differ far less than people tend to imagine. So contrary to popular belief, the sexes are actually much more similar than they are different. For example, out of 46 total chromosomes present in both males and females, 45 can be categorized as unisex, as I mentioned earlier. So very similar in terms of chromosomal development. Women and men share the same bodily and brain structures and functions. Men and women generally share similar levels of happiness and overall intelligence levels, as we talked about in a previous chapter. However, there are a few statistical differences that we could point to. Women typically begin puberty approximately 2 years sooner or earlier than males. And in terms of body mass, women carry about 70% more fat mass than males and about 40% less muscle. And the primary reason for this, which you may have already guessed, is due to childbearing. Women need far more access to fat than males do. And males typically, because of this, have an easier ability to lose weight than females. Females have to work a lot harder to lose weight in general because they do tend to have higher fat mass, particularly after they've given birth. On average, women are about 5 inches shorter than men, but actually we're seeing a trend in modern society of both men and women becoming much taller. You may have noticed this. I remember when I was in high school, I'm 6'4", and I was the tallest person in my high school. But now it's not uncommon to see many people my height or much taller even. So as a species, we are definitely getting taller, and that's certainly due to both genetic and nutrition reasons. Women are more sensitive to odors typically and express emotions more freely. Men are more likely to commit suicide or be diagnosed with autism. We're going to talk about the reasons for this later, but it is a significant difference that we see statistically. Women are more prone to episodes of anxiety and depression, and women live about 5 years longer on average than men. We'll talk more about this too toward the end of the chapter. Okay, and as I mentioned earlier, an individual's mother provides an X chromosome, while his or her father provides another X chromosome, in which case the individual will become female, or a Y chromosome, in which case the individual will become male. Although both males and females have testosterone and estrogen as well, for this matter. A lot of people don't realize this. Mostly males don't realize it. Females tend to know this before males do. Both males and females have testosterone and estrogen. Males just typically have more testosterone, and females tend to have more estrogen. The greater percentage of testosterone in males fosters the development of male sex organs during fetal development and additional sex characteristics prominent during puberty. Okay, I want to talk a little bit now about genes and behavior. Behavior geneticists have noted that alterations in DNA result in behavioral changes. Some of these traits, such as intelligence, for example, may be inherited, or we use the term heritable. We talked about this earlier in the chapter on intelligence. We do see a very strong correlation between genetics and intelligence level, although, as we also mentioned, environment does play a role as well. Researchers have demonstrated that individuals encountering identical circumstances may respond in different ways. This suggests a genetic influence upon behavioral response. With that background in mind, now I'd like to talk about a movement in psychology called developmental psychology. That basically is a study of cognitive, physical, and social development throughout the human lifespan. In terms of developmental psychology, what you will tend to see most often are developmental psychologists working in K-12 environments, although we definitely will see some people who work with seniors as well. Basically, you're looking at working with people throughout the lifespan, as we mentioned earlier. But most often, you'll see developmental psychologists working within K-12 environments with children with developmental disabilities. I want to talk a little bit about prenatal stages of development. We have 3 key stages. The first being the zygote stage, fertilized eggs, less than half of which survive beyond 2 weeks, that attach to the uterine lining. The placenta forms around the zygote and transfers nutrients and oxygen from the mother, about the size of a type period, so very, very small. This stage lasts only about 1 to 2 weeks after conception, so by far this would be the the shortest stage of development. Then we enter the embryonic stage, or stage of the embryo, development of major bodily organs and structural systems. Stage ends when key bone structures develop, approximately 3 to 8 weeks following conception. Now, most people just assume that the entire stage of development is the fetal stage, but actually the fetal stage is the final stage of development. It begins around the 9th week. A period of rapid development of major bodily systems, such as the digestive system. Stage lasts from approximately 9 weeks after conception until birth. I've spoken a little bit about twins previously, but we do have to differentiate between types of twins. Identical twins develop from a single fertilized egg that splits into 2 embryos, thereby creating genetically identical individuals, which is where the term comes from. Occurs roughly in 3 of 1,000 births. While genetically very similar, some differences emerge during development, such as unique fingerprints. Most common type would be female-female, and this is what we see consistently. Fraternal twins develop from 2 eggs fertilized by 2 sperm cells, and while sharing a common uterine environment, are no more genetically similar than traditional siblings. Most common type that we see here would be male-female. And this is important to remember. Basically, even though fraternal twins share the same uterine environment, they do not share identical DNA, like identical twins. It's almost as if you have a younger or older sibling sharing the same uterine environment and being born at the same time, but you're not identical in any sense in terms of DNA, unlike identical twins. But even identical twins are not completely identical, as you may know if you yourself are a twin, or if you know people who are identical twins. When you first see them, you say, there's no way I could tell this person from the other person. But after a while, you'll notice that you do notice subtle things, small differences between the 2 individuals. And most of this is due, at first, to the experience in the uterine environment, which even though they share the same uterine environment, they share it differently, which causes formational differences and changes that are unique to the individual. Also, environmental impacts once the twins are born can also cause variations. So you'll see differences in the twins once they are born, but they're very subtle in many cases. Okay, rates of twin births have been steadily increasing, and I always ask the question, why do you think we're seeing more twins? We're also seeing more triplets and quadruplets and so forth, for that matter. And I always ask that question, why do you think we're seeing this? And I get a lot of different answers to this, but if you think about it, we have developed some very effective fertility drugs over the past 50 to 60 years. And those fertility drugs are working very, very well. In fact, sometimes they work a little too well, and we're seeing more and more of these multiple births. Studies of identical twins separated at birth have demonstrated that heredity plays a significantly high role in personality development. We saw this as well with intelligence. We see that twins that are separated at birth tend to score very similarly on IQ tests. We also see this in terms of certain personality characteristics as well. Certainly not identical, certainly don't have identical personalities. That's not what we're suggesting. But they do have similar likes and dislikes and personality preferences. Okay, infancy and childhood. Maturation is an orderly sequence of behavioral changes and biological processes uninfluenced by experience or learning. And on the chapter of learning, we were talking about things that people have to be taught to do and how we learn. In this chapter, we're more concerned with maturation or development, which basically happens of itself. These are things that a child does not have to learn. They happen of themselves. A neonate is defined as a newborn infant up to 1 month old. The period of the neonate is associated with amazing built-in motor skills designed to enhance individual survival in an often hostile environment. Throughout infancy and early childhood, the individual demonstrates vast, genetically pre-programmed cognitive and motor skill development. Again, these are built into the system. They do not have to be learned. They happen of themselves for survival. And we've already defined cognition, but I'll mention it again here. Cognition may be understood as a complex network of mental activities involving remembering, thinking, communicating, knowing, and understanding. And again, just to break that long definition down, basically cognition refers to mental processes. That's the easiest way to remember it. Now, on your slide presentation, I have a few examples of behaviors that basically are either learned or products of maturation. I'm always interested in responses to these. The first being eating with a fork, which is usually the easiest. People tend to know that that is actually learned. That is not something we would do naturally. We have to be taught to eat with a fork. Otherwise, we would probably eat with our hands, as we see with very young children. Walking. What about walking, do you think? If you think about it, we have an expression that is a little bit confusing. We'll say, she learned to walk, which suggests that walking is something that we are taught to do. When in actuality, walking is a natural function, a function of maturation. If you never did anything with a child, if you stood back as they were developing and did nothing, they would eventually stand up and walk on their own. It may take longer. What we do is encourage them to walk sooner. So in that sense, we may have an impact in when they begin walking, but we do not teach a child to walk. Another behavior is speech. What do you think about speech? Is speech learned, or is speech something that occurs as a product of maturation or naturally? Well, we talked a little bit about this in a previous chapter. Speech is natural. It's a product of maturation. If no one ever taught you to speak, you would speak, or at least use some form of communication, such as sign language. Language is, however, learned. We have to be taught a language, but speech occurs naturally. Okay, I'll talk a little bit about personality, temperament, and heredity. Temperament is defined as an individual's tendency towards particular emotional intensity and reactivity levels. While some researchers contend that temperament is rooted in genetic factors, this assertion has proven difficult to confirm conclusively. So what we are seeing is temperament is something we are born with, but to what degree that temperament is genetic is still a matter of debate. And you see on your PowerPoint slide, there are three basic categories of temperament. Easy infants, welcoming, sociable, regular sleeping and eating patterns, cheerful mood. About 40% of infants fall in this category. So most infants are easy infants. They're very easy to be around. They don't cry a lot. They go to bed when they're supposed to. Just very, hence the name, easy children to be around. Slow to warm up infants, uncomfortable with new people and situations, withdrawn, shy, and passive. About 15% of infants fall in this category. This would be our very deeply introverted and very shy children. Difficult infants, highly intense, irritable, unpredictable, inconsistent sleeping and eating patterns. Accounts for about 10% of children, and as you see, that's a very low number. Most children do not fall in this difficult category, but when you're around a child who has a difficult temperament, you know it. They're always crying, they're always upset about something, you can't always put your finger on it. So it's as the name implies, very difficult to be around these children. It's very frustrating in a lot of cases as well. But here's the interesting statistic that we can talk about with temperament. About 35% of children do not fall comfortably into any one of these other three categories, which that would be the second most children behind easy infants don't really fall into one category. And what we mean by this is some children actually may be easy at some times, and they may be difficult at sometimes. They may kind of share either or both of those categories. So we can't say that every child falls neatly into them, but when one child does, it's pretty clear which one that they're in. And what we do see, if someone does fall clearly into one of these categories, it tends to persist or endure throughout life. Meaning that if someone is an easy infant, they tend to be an easy adult. If someone is a difficult infant, they tend to be a difficult adult. We just see this fairly consistently. I do want to mention briefly a few developmental disorders. I'm going to come back to disorders in greater detail at the end of the course. But within the context of human development, we do have to mention a few developmental disorders that occur as children are maturing, or at least disorders that we see early on in their development. The first being learning disability, broad term used to describe any number of challenges impacting an individual's ability to learn effectively. Probably the most common of these that we will see would be something like dyslexia, where a child may invert letters or numbers or even entire words within sentences. And in the past, this was a really big problem. Before we understood exactly what dyslexia is, teachers would assume that the child was incapable of learning, or they weren't intelligent enough to learn, which was incredibly a wrong turn. And thankfully, we have identified exactly what this disability is. It is treatable. There are workarounds for it, and a lot of people with dyslexia learn these workarounds. I always use the example of Tom Cruise, who himself has a very severe case of dyslexia, and he will just memorize his scripts prior to his movies, and that way he can avoid having to struggle to have someone kind of read it to him, and he memorizes that and goes on from there. So there are workarounds, and there are other things that are used often, but it's one of the more common learning disabilities that we see in young children. Communication disorder adversely impacting the individual's ability to use language or effectively communicate. And speech impairments of various types would fall into this category, and speech pathologists often work with children to overcome a lot of these issues. Attention deficit disorder, associated with notable inability of individuals to maintain concentration, may be accompanied by hyperactivity or impulsivity, in which case we would label this ADHD. Must be diagnosed by 6 to 12 years of age and be present for at least 6 months. We make this notation of at least 6 months because there are a number of challenges to children which we see, like disruptions in the home, for example, a divorce, things of this nature that can cause similar behaviors that look like ADHD but are actually caused by other factors. So we want to see this behavior persisting for a period of at least 6 months. May be associated with lower levels of the neurotransmitters dopamine and norepinephrine. When we're treating ADHD, and we're going to come back to this later, we're really looking at dealing with those. There may be problems in these, the way these neurotransmitters express in the brains of a child with this disorder. So we do have a certain class of drugs that will help with that. Developmental coordination disorder, a neurological condition affecting neural communication to the body, impacting coordination and motor movement, not to be confused with multiple sclerosis, cerebral palsy, or muscular dystrophy. These are other genetic disorders that may look similar, but are actually of a completely different class. Now we're going to talk about a number of disorders in the course whose names have changed over the years. This would be our first one, autism spectrum disorder, or ASD. In the past, basically people were categorized into three different areas, but what we have found is there was so much symptom bleed that occurred with this disorder. We're going to see this also in others as well, that it made more sense to look at the disorder in terms of a spectrum and how someone would fall along a spectrum. So this is a broad categorization including impairments in social functioning, performance of repetitive behaviors, and compromises in verbal and nonverbal communication skills. Includes former diagnoses such as Asperger's syndrome, verbal and nonverbal compromises, autism, impairments in neural synapse connectivity, and pervasive developmental disorder, mild or severe, informally used as a diagnosis in instances where criteria for Asperger's or autism were not met. autism spectrum disabilities appear to be strongly linked to genetic considerations. We are seeing this more and more. I'm going to talk a little bit about more this later on as to some possible reasons as to why we're seeing more cases of autism now than we have in the past. Intellectual disability characterized by challenges to cognitive and physiological functioning, such as Down syndrome, which we previously mentioned, wherein the individual is born with a third copy of chromosome 21. Okay, social development within the family. How much does your family impact your personality or who you are? And I always ask this question, based on your experience, do you have more in common with members of your family or with your friends? And if you analyze it closely, most people would argue they actually have more in common with their friends. And in some cases, you may have more in common even with a perfect stranger than you do with your family. And the obvious reason for that is you get to choose your friends. You don't get to choose your family. In many instances, you wonder, how in the world am I related to these people? Because there's so many differences. Now, there are things that you do share with your family, but these are not things that you might think, and certainly in terms of your own personality. Adoptive versus biological families. Studies have demonstrated that whether an individual is reared by biological or adoptive parents, he or she does not generally display personality traits similar to other family members, suggesting predetermined genetic factors. So even raised in certain environments, even with biological parents, you are still going to express yourself as an individual because you have your own individual genetic traits. Additionally, research demonstrates that a shared family environment has very little to do with individual personality development. Your parents try to impress upon you certain things, but you as an individual are going to behave in a certain way based on your own unique DNA. Now, where we do have similarities with our family, particularly with our parents, we see these in beliefs and attitudes, those kinds of things. Parents may have some influence upon individual values, manners, religious faith, attitudes, and or political perspectives. These are things that parents may definitely have an influence on. However, you may or may not even accept these. You may, while you live at home, but they may change over time, and you may develop your own ideas related to these. But as you see, these are not personality traits. These are external influences. Your personality is definitely your own. Okay, I want to talk a little bit about environment and genetic interactions. Although genes may play a significant role in personality development, environmental factors also shape who we are. Thus, while two people may share the same gene, the gene can ultimately respond quite differently depending upon unique experiences. And I ask the question, does a tall gene necessarily predict tallness? You're basically genetically pre-programmed to be tall, for instance. Does that necessarily mean that you will be tall? Well, the answer to that is no. Actually, that is not the case. Because let's say, for example, if you, for any reason, suffer malnutrition, malnutrition can stunt growth. Or let's say that you're exposed to a certain toxin or a certain drug early in life that can stunt growth. That could interfere with that genetic code that switches on for you to be tall. It could switch it off and you not be tall. And I do know of many instances like that. It is important to remember that neither genes nor environment contribute solely to personality development. It is more appropriate to state that genes and environment interact to produce unique personality structures. You cannot completely separate nature and nurture. They interact on many, many different levels. To some degrees, we'll see sometimes where nature impacts characteristics more and nurture sometimes interacts characteristics more. So impacts characteristics more. So in either way, they just basically interact rather than one dominating. Okay, this brings me to our first major theorist in human development, and basically his name is synonymous with the field of developmental psychology, and that is Jean Piaget. And as you're going to see as you read through your text and go through your PowerPoint presentation. Piaget was quite a brilliant researcher. He was a biologist, philosopher, and leading developmental psychologist. He was also a child prodigy. He was a child genius. Published his first paper by age 12. He was sort of like Mozart. Again, child prodigy, and absolutely an amazing thinker, and has impacted our study of human development ever since. So according to Piaget, cognitive ability follows a four-stage developmental process whereby the individual applies differing reasoning strategies in order to understand environmental stimuli. I'm going to come back to these stages in just a second. Before I do that, I want to mention a couple of terms that people often get confused, or they overcomplicate, and I want to make sure that you understand them clearly. The first would be schema. Schemas are particular situational frameworks or concepts that aid the individual in the interpretation and organization of information. Think of a schema simply as a concept. It's just an idea of how to do something. You have a schema for opening a door. You have a schema for picking up a pencil. You have a schema for turning on the television. This is just basically a concept of how to do something. Okay? Now, assimilation and accommodation are two terms that are often used by Piaget, and they look very similar, and students will often confuse these, and I want to clarify them as best I can, hopefully. Assimilation is the interpretation of new experiences in terms of schemas we have already developed. So if we develop a schema for picking up a pencil, we can use that exact same schema for picking up a crayon or picking up a toy car. We can go on and on and on. Once we have this schema, we can assimilate it into many different social situations. Accommodation is taking that same information and making an adaptation. Okay, so an accommodation is modifying or adapting current schemas so that new information might be incorporated into our overall understanding. So if we have a schema for picking up a crayon, for example, we can use that same schema to try to pick up a glass to drink some water out of, but if we pick it up in the exact same way, we can't tilt it, right? We'll end up we'll hit the back of our hand trying to drink. But we can make an accommodation, which is a change. We can make an alteration, and we can turn our hand to the side instead of straight up and down, turn it to the side, grasp the glass from the side, lift it to our lips, and we can drink effectively. So accommodation is just making that change, a little bit of a change to an existing schema that we have, and it expands our horizons vastly. Okay, the first stage that Piaget identified is the sensory motor stage. From birth to about 2 years of age, and associated with experiencing one's surroundings through the use of the senses, which is exactly what we're talking about here. Sensory being senses, motor being movement of the body, the limbs, such as touching, looking, tasting, smelling, and hearing. And motor skills associated with grasping and mouthing, completely associated with grasping and mouthing. When you're a very, very young child, that's pretty much all you have to understand your environment. You basically have to kind of grasp everything, and I call this hand-to-mouth tendencies because everything that goes into the hand will end up in the mouth. Huge lack of visual acuity, and we see this with very young children. For lack of a better term, you'll see very young children appear almost high in nature. Their heads will bob back and forth. They're trying to focus on what they're looking at, and it's very difficult for them. To them, you look like a kind of a big blob. But eventually, and very rapidly, that acuity improves, and their vision improves dramatically, and they can see much more clearly. General strain or anxiety we see at this age. Most young children would prefer to stay close to their primary caregivers, not wander off too much. They want that security. Key achievement is development of an awareness of object permanence, or an understanding that things exist even when they are not directly perceived by the individual. Young children at this stage, according to Piaget, do not have this ability of object permanence. So basically, if it's out of sight, it's out of mind. It doesn't exist. This is why peekaboo is such a fun game for children in the sensory motor stage. You cover your face up, it's gone. You move your hands away, and they start laughing because now your head has appeared out of nowhere, according to Piaget. And also, you'll have family dog comes into the room. Child plays with the family dog. Family dog leaves the room. Where's the family dog? Gone. Completely disappears. They have no concept of that dog beyond when it is in their immediate presence. But by the end of this stage, the child does develop object permanence, and they do realize that things do persist even though they're not in their immediate view. At that time, the child moves into what is known as the preoperational stage. From 2 to about 6 or 7 years of age is associated with an attempt to understand things in terms of words and images. Intuitive reasoning begins to develop, however, logical thinking is still limited. We look at it sort of like a 2 steps forward, 1 step back almost. With each stage, you're going to develop, you're going to see improvements, vast improvements in certain areas, but you're also going to see limitations still. And that's what we would see here. Key phenomena associated with the preoperational stage would be pretend play associated with the development of symbolic functionality or the ability to understand that one thing can represent another, such as Spot as a family dog or a toy block can be used as a car. And you'll see children do this all the time. They want to play with a car. They don't have a car, but they do have a toy block. What do? They'll take the block and they'll make car noises and push it around along the floor. And so in their mind, hey, this is a car. But do they know it's not an actual car? Absolutely. This is what this pretend play is all about. Symbolic functionality. I can make this block look like a car or pretend like it's a car. Hallmark of this stage is something known as egocentrism, or the belief that everyone else sees or thinks what the child is seeing or thinking. And basically, children, according to Piaget, whatever they think, whatever they see, whatever they hear, they think that everyone around them is having the exact same sights or thoughts. You've seen this before if you've ever had a child in the house watching a movie or something, and you're in another room, and the child comes in and says, "Why did the princess do that?" Well, they assume you don't know what they're talking about, but they assumed you were watching the exact same movie that they were watching. Piaget had a very interesting experiment that he used to demonstrate this. He would have a child sit on the side of this mountain scene on one side of the table, and he would sit on the other side of the table, and he would ask the child, "What do you see?" And the child would say, "I see a cow, a barn, a tree," whatever they saw. And he would ask the child to tell him what he saw. Well, the child didn't even think to get up and walk around to the other side of the mountain scene. They just simply said the exact same thing that they saw on their side because they assumed that he was seeing the exact same thing when in actuality he was not. Now, the idea that someone else has unique thoughts, that is called theory of mind. And Piaget just did not believe that children in the preoperational stage had a really clear theory of mind. He really believed that they pretty much thought that everybody sees and hears whatever they see and hear. But there is evidence today that we have that some children seem to have a very early theory of mind that develops. Okay, individuals in this stage of development lack the understanding of conservation, or that volume, mass, or quantity do not change despite rearrangements or changes in object forms, such as placing fluid in a taller, thinner container does not mean that more fluid has been added. Piaget had a very famous experiment that he liked to do to demonstrate this, where he would have two short, sort of wide glasses that he would put in front of a child, and he would fill them about halfway up with a liquid. And they were the exact same height in both glasses. And he would ask the child, "Are these the same or is one more?" And the child would have obviously say, "These are the same." Then he would take one of the glasses and pour the contents into a really tall, skinny glass, which of course made the fluid go up much higher than it was. And he would ask the child, "Are these the same or is one more?" And invariably, children in the preoperational stage would say that the tall, skinny glass had more in it, even though nothing had changed in terms of volume. It just looked like it. And we see many instances of this, many examples of this. children kind of learn this early on. Older siblings learn this because if you have a pizza sliced up, for example, and there's one really giant wedge and there's one really skinny little tiny wedge, the older child who has developed this understanding of conservation will grab the big wide wedge for themselves and give the younger sibling the little skinny wedge, and the younger sibling is perfectly fine with that because they both have one. They don't understand that, oh, yours is bigger. Just one is one, right? Okay, now once conservation develops, then the child enters the concrete operational stage. Concrete operational stage exists from about 7 to 11 or 12 years of age and is associated with the development of logical thinking and mathematical abilities. Here we're really moving ahead. We're stepping ahead, and we're moving into the ability to form much more complex thoughts and handle more complex mathematical calculations. A key phenomenon is understanding of conservation is achieved as a result of acquiring reversibility skills, or realizing that apparent changes in shape, number, volume, organization, or mass can be reversed and need not imply actual changes. So here, children definitely can see the difference between a wide slice of pizza and a very skinny slice of pizza, or the differences, and then they can know just by putting the volume of water in one glass into another, it doesn't really change anything. Ability to perform mathematical operations and apply logical thinking develops. And this age, if you'll think back to when you were in school, in elementary school, this would be when you were starting to learn multiplication tables. You're starting to learn long division. Your mathematical ability improves greatly in the concrete operational stage, although again we do still have limitations, as we see here, because children will tend to lack hypothetico-deductive reasoning abilities, or the ability to apply logic to hypothetical situation. Basically what you see an ability of children to come up with very creative ideas about things, but because they do not have this follow-through, this hypothetico reasoning ability, which basically tells you, okay, if I do this, then this will probably happen. That is still very limited. So you'll see children at this stage climbing up into trees and jumping out and breaking an ankle or something. This age group is responsible for the most visits to the emergency room. They'll try to ramp their bicycle over a ditch and cause injury. It's fascinating because they come up with these really creative ideas, but they don't realize, they don't have the follow-through ability to see what could happen. So we have these errors in judgment resulting in accidents. The final stage that Piaget discussed was what we call the formal operational stage. From about 11 or 12 years of age through adulthood, associated with the development of logical abstract reasoning abilities, development of hypothetico-deductive reasoning abilities, or the application of logic to hypothetical situations. For example, if all trees have leaves and an elm is a tree, then an elm tree must have leaves. Despite this development in early adolescence, however, certain logic and risk centers in the brain may not completely mature until later. And this is one thing that we definitely see. Once a youth develops this ability, they actually have the knowledge of follow-through, this hypothetico-deductive reasoning. They can see, okay, if I do this, then this will probably be the end result. But even having that knowledge does not mean they will necessarily apply it. And this is why we see all of these issues that happen during adolescence. For example, a young male may know that speeding could cause them to get a ticket, or it could cause them to have an accident. But do they still do it? Yes, they still do it, which is exactly why we see such high rates for males between the ages of 16 and 25 in terms of auto insurance. The statistics are very clear that males in this age group are the more reckless drivers. Even though they know that they should not do this, the majority of males still participate in these reckless behaviors which can cause them problems in the long term. This is also engaging in other behaviors like substance abuse, using drugs and things of this nature. All of this would fall under, you know that these things could be dangerous for you, but yet you overlook that and you still could engage in them. So the risk factors not developing until later cause a lot of problems for adolescents in terms of this. Usually the risk centers of the brain are fully developed usually by the early 20s to sometimes in some cases the mid 20s, and you see a lot of these behaviors fall off after that. Not in all cases, but in most cases. So you see people engaging in much less risky behavior once those risk centers have developed. Okay, Piaget in retrospect. While Piaget has been recognized by Time magazine as one of the 20 most influential scientists of the 20th century, alternate developmental theories have been promoted and challenges to certain Piagetian propositions have been published. You probably see in Piaget, you recognize a lot of things that you may have experienced in your own life, or certainly if you have children, in the lives of your children. But some of his propositions have been challenged, one of which is this issue of object permanence. Some researchers have noted that apparent deficiencies in object permanence may merely reflect physical rather than cognitive limitations. If you think in terms of what a child can do physically early on, they're very, very limited. Children can't always demonstrate that they have a cognitive knowledge of something. They can't express themselves well, and their bodies won't always allow them to demonstrate this. So the argument here is that it's not so much a cognitive deficit that the children have. It may be just physiological limitations. Information processing theory. This holds that improvements in cognitive functionality are the result of increased abilities in terms of working memory rather than clear-cut developmental stages. And you'll remember in Piaget, you basically have a cognitive development, and then you'll move on to the next stage. Well, according to this theory, that's not actually what's happening. What's actually happening is the memory is slowly improving, and as the memory ability improves, it only appears that people are moving into different stages. So an example might be if you are your first day in school in kindergarten or first grade and you don't know where your classroom is. You go to the principal's office, they tell you where your classroom is. The second that door closes behind you on your way to your classroom, you forget. Because young children just do not have the same working memory ability as do older kids and adults. You right now, your first day on campus, you go to administration and you ask, "Where's my classroom?" They tell you. Usually what you will do is you'll put it into working memory. You'll say, "Oh, my room is 101, 101, 101." You'll keep repeating that again and again in your mind, and then you're able to find it much more easily. So that's the argument there. But despite these challenges, Piaget continues to withstand the test of time. And again, as I mentioned earlier, his name is definitely synonymous with the field of developmental psychology. Now, having said that, there are other theories and theorists who look at the same data that Piaget looked at and came up with a little bit different conclusions as to how they look at the way humans develop. The first would be Lev Vygotsky, who developed the sociocultural approach. According to Vygotsky, cognitive development occurs as a result of parental and teacher guidance within a cultural context. For Vygotsky, the reason the way people develop rather, is through learning from their parents, learning from their teachers, taking everything in that the teachers and parents provide. The use of language is a key component of this process. Children begin to use self-talk as a learning tool. And you probably have heard children do this. If you tell a child, be very careful going down the stairs because it is dangerous, when that child starts going down the stairs, you may actually hear them repeat this. They may say, I am walking very slowly. I'm being very careful because this is dangerous. And they're just repeating this, and that sort of etches in their minds how things are done. New words serve as a scaffold upon which higher levels of learning can be built. If you'll think in terms of maybe a mason or a painter or someone who would use scaffolding in construction, this is basically the same idea that Vygotsky had. Children learn words and concepts. They serve sort of as a scaffolding, and they just keep building upon that and building upon that as they grow older. Now, another thinker would be Erik Erikson. Erikson was actually a follower of Sigmund Freud, and this will make a lot more sense later when we discuss Freud's psychosexual stages of development. But Erikson liked the way Freud had developed his psychosexual stages, but he looked at it more in terms of psychosocial stages. That was more of his orientation. So he basically adapted some of Freud's ideas into this psychosocial stage developmental theory. So heavily influenced by Freud's psychoanalytic theory, Erikson developed 8 psychosocial stages, each with associated conflicts that must be resolved, that all individuals must successfully negotiate as they develop. And on your PowerPoint, you can see these stages beginning with infancy, starting with birth to 2 years old, basic trust versus mistrust. Is the world a trustworthy place for me? And this is established very early in life, according to Erikson. And then you look at it in terms of basically the primary caregiver's relationship with the newborn infant. How strong is that bond? How much can that infant reliably depend upon its mother for sustenance, for nourishment, for clothing? Because according to Erikson, if you can't reliably depend on your mother early in life, what do you think that will do to your trust issues? Well, obviously, it will impact them greatly. And people who have these trust issues throughout life probably, according to Erikson, are still fixated or invested in that very first stage where they could not trust their primary caregiver, and so they can't trust anyone really. The next stage would be early childhood, 2 to 4 years old, autonomy versus shame and doubt. Am I okay and normal? Even at this very young age, we begin this process of comparing ourselves with others. Am I like everyone else? Am I a normal person? Am I okay? Then we have the preschool, 4 to 5 years old. In this case, that's when children would be entering preschool. Initiative versus guilt. Is my behavior acceptable to others? This one is very much socially oriented, where am I an acceptable person in my surrounding to my peers, basically. School age, 5 to 12 years old. Industry versus inferiority. Will I be able to survive in this world is the main question. As I'm growing up in school, can I develop as a person that can actually survive in this hostile world that I am in? Adolescence, 13 to 19 years old. Identity versus role confusion. Who am I now and who can I become? And in adolescence, we see this very strongly. We do see cliques developing before this, but we see it most strongly in adolescence. These cliques are very strong and very profound. And so you're basically asking yourself, how do I fit in here? Can I improve this? Will I always be like this? Or how will I fit into this world? Early adulthood, 20 to 39 years old, intimacy versus isolation. Is it possible for me to have love? And of course, in early adulthood is when most people are seeking a mate. And they're dating and doing whatever they can to establish more intimate relationships. And there's always that question, will I be able to find this, or will I always be isolated from others? Adulthood, 40 to 64 years old, generativity versus stagnation. Will I make a difference in the world? This is the stage where people try to rise into their careers. They try to find what they're supposed to be doing in life and making a contribution and being fulfilled through that contribution. And finally, maturity, 65 until death, ego, integrity versus despair. Was I successful in life. You're looking back over your life into the things you accomplished or failed to accomplish. And basically, are you falling into despair because you did not contribute what you wanted to? Or are you feeling very good about what you did, the contributions that you made in life? And again, with each one of these stages, there's that conflict that has to be resolved, or you can still kind of be fixated in that stage for the remainder of your life if it's not somehow worked out. Okay, this will conclude part one of the lecture on lifespan development. Thank you.